Excellent. Thank you, Forrest. We do have several questions to get to.
Yeah, absolutely.
Thanks for throwing those up. So Nicholas asks, if Kubernetes doesn't do the compute, why add the overhead of Kubernetes at all instead of just traditional RPM dev install services? It's a great question. Thank you, Nicholas, for that.
So Fuzzball is built out of right now 2 pieces, and there's a third one coming. The base piece is called Substrate. This is what runs on the compute cluster itself. Fuzzball Orchestrate is what orchestrates all the different Substrate instances to do all the different things that you saw Forrest just demonstrate. Everything from ingress of data, managing the workflows. And when I say the workflows, it's much more than just what you have in your YAML file. There's a lot of context in that, in the workflow that Fuzzball has to manage. Again, all the ingress, the egress, the volume setup, setting up containers, downloading containers, building the images for those containers, persisting and storing those containers, just to say a few. There's a lot of things that it has to do. Fuzzball itself, or Fuzzball Orchestrate as itself, runs as a microservice platform. So there's a lot of different pieces to it, and they all fit together via microservices. So being that Fuzzball Orchestrate is a microservice or a cloud native platform, it wants to run on some sort of microservice solution. And Kubernetes is just the one that most people are very comfortable with and very familiar with at this point. Also, many of the clouds will offer Kubernetes services. So it's very easy to stand up Fuzzball Orchestrate on top of these various services. So once you have this Fuzzball service running on top of Kubernetes, you can now start running workloads. So one other piece as well is, I believe, Forrest, you ran all of these different workflows in AWS. In AWS, you can kind of think of it as it scales as needed, right? And it'll bring, so every time Forrest would run jobs, it would actually spin up the appropriate number of instances, run those on the right type of instances, and then tear them down when it's all done. If you're running this on-prem, you have a finite number of compute resources. So it will appropriately schedule. We didn't talk about the scheduling features, but it will be able to schedule all of those workflows appropriately for running on an on-prem solution, which again, the scheduling parameters of that is very different than scheduling in the cloud. Hopefully I answered that. Fuzzball Substrate is a traditional RPM dev installed service. Fuzzball Orchestrate is just a lot more complicated.
I like that. It's just a lot more complicated. We'll get into that later. That actually
depends.
True. James, thank you for posting a question here. And he says, are you showing this in the cloud today? And you mentioned hybrid cloud. Will this be a true hybrid cloud platform?
So I just mentioned that there's 2 pieces of Fuzzball that we're showing off today. And there's a third. So there's Substrate at the bottom, Fuzzball Orchestrate, which orchestrates all the different substrates. And then there's Fuzzball Federate, which sits on top of Orchestrate. Because, as Forrest mentioned, there's no SSH involved in this. The entire thing is API driven. It makes it very easy now for us to extend Fuzzball clusters and unite them. So to the question, yes, we can actually, absolutely, you can run a Fuzzball Orchestrate instance in AWS in one availability zone, a Fuzzball Orchestrate instance in a second availability zone, Fuzzball Orchestrate instance in a different cloud and on-prem, and then federate them all together. And when you do that level of federation, Fuzzball Federate is going to be making meta orchestration decisions based on things like resource availability, cost, how much is it cost to run? So obviously if you've got on-prem resources, it may be much cheaper to run than having to go spin up cloud instances. And then lastly, data. Where's that data? And when you look at all of these together, you actually get some really interesting possibilities in terms of scheduling. So as an example, well, it's cheaper to run on-prem, but my data's up in S3. All right, now you have to start making decisions on when and how is that job going to run. And those decisions are tuned via policies by the organization. The organization will control that. Today we are releasing Fuzzball Substrate and Fuzzball Orchestrate. Fuzzball Federate, keep an eye out, it's coming soon.
I like that, it's a good tease. Oh, another question from James, awesome. Does Fuzzball know what resources you have available, or are you guessing? Or what if you say, I want this resource and that one, like you were doing, Forrest, but then that resource actually doesn't exist or it's being used?
Forrest, you want to grab that one?
Yeah, so Fuzzball does know what resources you have available in the cloud. As I believe I showed at the very start of that, there's definitions that you can set that map to, for example, different instance types out on the cloud provider. So you can set up different compute node definitions, for example, that map to different AWS instance types, like their P3 GPU series, their C5N, like CPU series. You can, like I said, essentially map those to different instance types. On-prem, Fuzzball becomes aware of what resources it has kind of as a part of the bootstrapping and setup process with orchestrate and substrate there. So it kind of is able to programmatically determine what it's aware of, what's out there, what resources are on those nodes, etc. If you say, I want this, but that resource doesn't exist, in the cloud, you will essentially just get a workflow failure that says no sufficient provision definitions exist. And you'll have to head to your sysadmin and get a definition put to that. So that's just if like your system doesn't have a matching resource defined in it. If it does have a matching resource defined, it's, as Greg mentioned, going to just reach right out to the cloud provider, provision that instance type live, and then route it back to the workflow to use as the compute resources for that. On-prem, it essentially does the same thing. It takes some of the compute resources that are available and assigns them to the workflow. But yeah, so Fuzzball is aware of what you have available. You can define that. You can also, it discovers some of that on its own. And then if you say, I want this, and it doesn't exist, but it knows how to find it, it'll go spin it up or like get some of it. But if it doesn't exist and you don't have it defined, you just get an error, as you would expect. Get some different nodes working.
Thank you, Forrest. So I think that kind of leads into the next question from Sylvie. Yeah, what is the overhead like on this? Since you're actually putting something on each compute node, what is the overhead like?
So this goes back to, I guess Forrest and I are tag teaming. I'll take this one.
That'll work.
Jump in if there's anything else you want to add. It kind of goes back to one of the earlier questions about Kubernetes versus, why use Kubernetes and versus not. So a lot of people that are trying to solve these problems are actually trying to go the other direction, where they're basically saying, we know what Kubernetes is like. We know how that operates. Let's just go run everything in Kubernetes. A lot of the feedback we got is Kubernetes is just way too much overhead, and you're not getting a lot of the performance out of the underlying resource due to Kubernetes just honestly just getting in the way. It's just too big. So we spent a lot of effort, and this is why Fuzzball Orchestrate sits on Kubernetes while Fuzzball Substrate does not. Fuzzball Substrate takes a lot of the experience that we glean from open source applications like Singularity and Aptainer, and knows how to run these containers and know how to run this infrastructure in a way that gets out of the way and gives you direct access to that underlying resource in as the most efficient way as absolutely possible. So we have benchmarked Fuzzball in a variety of different ways at this point, and we are getting bare metal speed always.
Great answer, Greg. Thank you.
Really quickly, I know we're very close to time, but just to elaborate a bit on that, we've just to put some numbers on kind of performance and overhead. We've run benchmarks on some Fuzzball clusters like HPLAI. We've found that we've got the numbers out of those that we've been told by different manufacturer, that type of thing, in that case, that we should get out of that benchmark. So we've seen that Fuzzball provably doesn't add overhead to your HPC. We've also run up in the cloud comparing, doing kind of benchmarks around GROMAX, comparing to some of the numbers AWS has published, and we are dead on to what's out there. So this is, as we've noted, this adds no performance overhead, and like a more standard Kubernetes installation does. And we've got numbers that we've had to back that our overhead is minimal.
Appreciate that. Thank you, Forrest. Oh, Ian, what's up, Ian? Thanks for watching. Okay, so I know that we are like at time of like how we usually do about an hour, but this is really exciting. This is our release that we've been working on for years. And so we're going to stay on and answer a few more questions. Okay, Ian, for those who are familiar with workflow solutions for the life sciences, for example, Cromwell, I'm not going to read that there, blah, blah, blah. Is there any possibility of a brief comparison or contrast to better appreciate Fuzzball other than just the name? Thank you, Ian. It is a cool name.
Forrest, you want to take it or you want me to?
My understanding around GATK and like Nextflow, things like that, are that those are mostly workflow description languages that give you a very robust way to codify a workflow. But Fuzzball includes a massive software platform backend that actually goes ahead and doesn't just provide a workflow engine, which is one of the microservices that's a part of the Fuzzball Orchestrate stack. There's a workflow engine that takes in users' workflows, parses them out, sends the information to the different parts of the other microservices that it needs to be in. So overall, I would say the biggest difference is that Fuzzball versus like Nextflow, that type of thing, Fuzzball is not just a workflow description language. It's an entire Kubernetes-based platform that you can deploy itself as a cluster, not just take like workflows and run it versus existing resources. Fuzzball is its own entire computing platform that a workflow engine like that is just one component of.
The other thing I would just mention as well is there's nothing stopping you. As a matter of fact, it's encouraged to use those workflow managers inside of Fuzzball. So you can absolutely use that. You can provision out your resources with Fuzzball and then leverage all of those same tooling that you're already familiar with.
I've done things like, for example, taken existing Nextflow workflows and converted them fairly simply over into Fuzzball workflow formats as well. So it's all kind of translatable fairly easily.
We can also, in theory, Nextflow is a little specific as well because it can actually spin up cloud resources and interact with clouds. So we've actually brainstormed in terms of, can we leverage Nextflow as a Fuzzball client? And so that may also come in the future.
Very interesting.
Theory, we haven't actually done it yet. So theory, it should work. By the way, hey Ian, great to see you. Well, kind of.
So here's a good question that Nicholas asks. Will Fuzzball be free open source with the option for paid support like Slurm? We give this one a lot. I'll let Greg answer that one.
Yeah, so it is our intention to open source Fuzzball, but we're not going to open source it on day one. We put a lot of research into this, a lot of work into this. And to be blunt, some of the feedback that we got from some of the other companies in HPC is, we're looking forward for you to open source this so we can go and run this and sell it to our customers, again, with not including us. So we are not open sourcing it simply because we want to encourage good behavior and good partnerships with our wonderful partners. So that's our initial goal. As a purchaser of this, we've got no issue whatsoever with providing source code if that's something that you're interested in. I'd be happy to provide source code licenses.
Thank you, Greg.
Ian's back. Okay, enough of that. Thank you. I'm getting a great sense from the excellent UI. Yes, it is. But I'm gapping on the execution and overall architecture other than use of containers from any repo.
Yeah, there's a lot in terms of the amount of architecture that we built into this. So again, it starts at Substrate, working up from there. Substrate is a container runtime. Even though we took and leveraged a lot of the knowledge we had from Singularity and Aptainer, we didn't use any of that code, actually. It is a complete new container runtime, specifically about and leveraging APIs to control it completely. So it is an API-based container runtime. That API uses something around the idea of leasing. So you can make a request to Substrate. I'm interested in this 8 GPUs, 24 cores, this much memory, and so on, this architecture, and so on and so forth. And Substrate will say, I have that available. here's a lease I can provide, and so on and so forth. Now, Orchestrate will manage all of the Substrate instances for you. So as workflows come in, Orchestrate will know what each one of the Substrate instances are doing, but at the end of the day, each Substrate instance itself is the source of truth. So it will confirm and check, and then it builds a graph of all of the different places that all these different workflows can run. It breaks apart the workflows and then runs everything on that platform. Again, it also does data management. So it'll do pulling in data, volume management, managing the volume. It runs on parallel storage as well as straight NFS, as well as local. Different types of volumes we can manage and we can build. Does all of that embedded into the platform. So it is an incredibly robust compute and orchestration platform specifically for performance intensive computing as a service.
Thank you. We have more. Keep going. So Nicholas asked again, what kind of metrics are available to admins? So he's looking for something like XDMoD from Slurm. What do we have in Fuzzball?
Horace, you want that one or you want me to?
The metrics backend side of it is, the latest status of that is a little bit more of an engineering question. I know that we have, for example, wired up our Fuzzball installs to Grafana and different common logging tools like that. And we've been able to go in and see how the cluster is running on EKS, all that stuff. So the best thing I can say here is that it works with, for example, logging platforms like Grafana to ingest the logs from a Fuzzball cluster and put those into a searchable format. Greg, I don't know if you have anything to add there.
Yeah, I would just say as well from the administrative side, it's using Kubernetes. It's using a more traditional enterprise stack on the Orchestrate side. So all of the typical tooling that you have for monitoring a Kubernetes cluster, you can use on the Orchestrate side. On the Substrate side, we're as close to bare metal as absolutely possible. And in that side, you could just use Fuzzball in terms of what it is providing, which, to be clear, it's not a huge amount today. It's enough that you can get by, you can figure out what everything's happening and whatnot, but you can't do kind of high-level profiling or real-time metrics or analysis on what jobs are doing through that. If you wanted to do that, there's a variety of solutions you can use, as you mentioned. Really, it's just then a matter of just tallying that data back up and how do you want to present that back to the users. But yeah, Fuzzball is very, very flexible with regards to that.
Okay. Hey, are you guys going to, how do you pronounce this? ISIC?
Just
ISC?
ISC. Yeah.
ISC. What is that?
So the International Supercomputing Conference. So it's the Europe version of supercomputing in a nutshell. Fantastic conference. I'm not planning on going, and I think we are sending some people. But yeah, we're still figuring that out. There will be at least several of us over there. We're a pretty big company at this point. Well, big, right? I guess it's all relative. For me, it's a pretty big company, and we're at about 85 people right now. So, and we are international. So, we do have a number of people in Europe. So we'll probably send some people from the United States over, as well as have some of our European contingent join us over there. So yes, but not me.
I have maybe a silly question, Greg. Does Fuzzball really take away the need to have a head node? Is that?
Yep.
Can we just get rid of that? Is that gone now?
Yeah, it's complete. It is gone in a traditional sense. So what Rose is asking is, in a traditional Beowulf architecture, we typically see things like you have a control node sitting up on top, and you've got all of these compute or sub nodes sitting below. That control node acts as an interactive server where people will SSH into that control node and then do all of their kind of major interactive work, and then interact with the scheduler that will then run the jobs on the compute resource, on all those compute nodes. Fuzzball does not have the same architecture, and this is what I was referring to earlier. Fuzzball is a new way of looking and thinking about high-performance computing systems. And there is no kind of control or interactive system as we've had in the past. Now what we have is the notion of APIs. And there's a number of different interfaces and tooling you can use against those APIs. And it turns an HPC system more into a computing appliance, really, just a massive scaled computing appliance. So you're now interacting with this giant computing appliance via these APIs, which again, users don't usually interact with APIs, but they're interacting with the clients that are communicating over these APIs. So you can use a Fuzzball cluster, even no matter wherever it is in the world, via your laptop or via your workstation. And again, just connecting and leveraging these APIs.
So that brings up a question about security, which I imagine, just because I've known you for a little while, that's top of mind, like making sure that I imagine that Fuzzball is more secure, but can you touch on that?
Yeah. So one of the biggest difficulties or challenges with securing a traditional HPC system is the fact that you are allowing, over SSH, over a secure shell, you're allowing people to have full access to that interactive resource up on top, and then to the compute resources when their jobs are running. And it's very hard to validate that a user coming in is in fact the right user, right? To start it off thinking about passwords as an example, right? A password is something that only you know. Well, that's the hope, right? Only you know that. And then you can use that password to go get access to the system. But what people found is it's pretty easy to either brute force or hack passwords and get in. So now all of a sudden people are getting in with your private password, but they're hacking it, right? So then we started using one-time passwords or additional, tokens to get in. So multi-factor tokens or multi-factor MFA, multi-factor authentication, to get into these systems. But again, that just kind of solved the problem for a little while. Giving users full access to pretty much do whatever they want is a very difficult thing to secure. Fuzzball, because everything is going through those DSLs that Forrest was showing, those workflows, everything is defined. You can reproduce, you can replay, and you can audit every single action that's happened. As a matter of fact, all of the data ingress and egress could be completely locked down to the point where we're actually getting authentication or authorization for any sort of IO going in or out of the system via another source. So if a lab or classified facility has limitation in terms of where they can pull data from or who can pull that data or what applications are allowed to be used against that data, we can integrate that via the ingress and egress. And we can also lock down when the job is running, we take it off the network. So they have to do all of their ingress and egress via that section of the DSL. So we can now start securing these workflows in a way that honestly, we just haven't been able to do before. And it gives a lot of capability in terms of management, right? This is the type of thing that a CISO or somebody who's really focused on the security side is going to be very interested in making sure that everything is auditable, it's reproducible, and it's secure. Not just secure from a hacker perspective, but secure from a supply chain perspective. Keep in mind, everything that we're running now is also coming out of something that can be verified and validated. Each one of those containers can be validated. So, excuse me. So we can very easily have complete transparency on everything that's happening and then trust on everything that's happening. So yeah, security is definitely top of mind.
Yeah, thank you for that, Greg. I feel like we've kept you a little bit longer. I think you might have a couple other meetings to go to, but thank you so much for coming on and sharing with us the story and building this amazing company and releasing Fuzzball and making it fun and awesome. Really appreciate your time being here. And I don't know, Zane, if you have something else to say, but you guys, we are open. We are open for business. We are ready for, your comments, your questions. You can go to our website, you can schedule with us and dive a little bit deeper onto how Fuzzball can really benefit your environment and how we can work together. And we'd love to chat with you. So leave a comment, leave a like, say hello, share with your friends, schedule a meeting. We're here for you.
Absolutely. Thank you all for watching. And I want to thank the engineering team. I know you guys have put a lot of time and a lot of effort into this. So we really appreciate it. Forrest, appreciate all the work that you've done. I know you spent a lot of time working on these workflows to be able to show people and show off Fuzzball. And it's been fun watching you over the last almost 2 years now, play with this thing and watch it grow. So really appreciate everybody out there. Like Rose said, go like, subscribe. If you want to talk to us more about this, go to the Fuzzball page and sign up and give us some time. Appreciate it.